There are three types of test data. There's normal data, which is data the program normally accepts. So like if the program is dealing with percentage marks in a test, like 50% is an example of normal data. Extreme data is data at the limits of what the program should accept. So in the test scenario, that would be 0 and 100%. And then we have abnormal data, which is invalid values. In this case, that could be anything from like 200%, because that's not possible, to a string of hello, because it shouldn't take a string at all.
Next.
Yeah.
Oh, sorry.
No worries.
I think you should be able to control it.
Yeah, it didn't want to at all, so I just left it. Verification, validation. So the terms relate to two different things. Verification, validation on data input. Verification ensures that data input is the same as the original source data. A way to do this is by having two people entering the data so they can check against each other. Validation ensures that data entered into the system is reasonable. You can automate that. With regards to testing, verification ensures that the software meets specifications. So that, as you'll see later on, that's a type of static testing. And validation ensures that software meets requirements for a customer and is appropriate for its intended use. Because if the customer can't use it, it doesn't really matter how good the software is. Next slide. So black box or functional testing. So it treats software as a black box. You don't know what's inside it, don't know how it works, and it doesn't consider it at all. It just tests that the software works as expected. It's performed by dedicated testers. A developer doesn't perform and you don't need any programming knowledge. It's less time consuming than white box testing, but it's much more difficult to automate functional testing. In contrast, structural testing or white box testing, the internal structure of the software is known to the tester. Programming knowledge is generally required, so it's performed by software engineers. It tests the logic and code quality of the software because, for example, a function that takes 10 lines to just print a string is much worse than something using system.out.println. It is more time consuming than functional testing, but it's more easily automated and software tools are developed to do this. And it finds hidden errors in the code. For example, a string that if let's say I want to add a list of numbers as my function, and the function's code just multiplies two numbers. If the list of numbers just contains 1 and 1, the output is fine. So functional testing thinks that it's fine, but the white box testing will pick up the fact that it's not correct. User acceptance testing. Testing to see whether a user accepts the system is important, otherwise users aren't going to use it. So for example, an application might work perfectly, but if it's a command line interface instead of a graphical user interface, users are probably less likely to use it. Obviously depends on the users. If we're targeting developers, for example, it might be the other way around. They don't want a graphical user interface because it's more complicated. The happier users are with a product, the more likely the developers make profit, which obviously increases the importance of user acceptance testing. So static testing is testing software without executing code. So this can be manual, for example, walkthroughs or reviews, or it can be automated. Software tools have been developed to assist developers with static testing. The photo shows IntelliJ performing static testing for me. Testing is often implicit. Sometimes the developer does not need to consciously make changes. So small syntax errors like typing sys10 instead of system, IntelliJ, for example, will likely change that for me. So that's implicit. And it exclusively involves verification. It does not involve validation. Dynamic testing. Dynamic testing occurs when a program is run. It does not, I should say 100%. It does not need to be performed when a program is 100% complete. In fact, modular testing is encouraged because if you wait the entire way and something doesn't work, and it's, for example, it's an issue of the superclass, then you have to go and change every single thing in all subclasses, for example. So modular testing is encouraged. It involves both validation and verification, and it is used in both functional and structural testing. Yeah, that's dynamic testing. Alpha versus beta testing. Alpha testing is conducted by internal employees, performed on site, and it's completed before software is made available to the general public. Beta tests are conducted by end users who are non-employees of the organization. It's usually performed off-site, and it can involve the suggestions of users. So beta software can be closed or open, so you can have an open beta for a game where all players can provide feedback, and you have a closed beta where developers invite people who sign up on a waitlist to test the software and provide feedback on it. Yeah, there's a couple of other types of testing. So there's dry run testing. A developer mentally runs the algorithm to ensure it works, for example, by using a trace table, although that's not particularly useful. Debugging is finding and correcting errors in programs. This can be automated by your IDE, or it can be manual. It's obviously manual when you're not using an IDE. Unit testing is when individual parts of a system are tested separately. This is important because you can then test your program as you build it rather than testing it at the end. Whilst in integration testing, each part of the system is tested together to see that it works. So that's just an example of unit testing because the idea sort of makes no sense. So in this piece of code, I've created two functions. One which is called, it's a bit small, but one's called good concatenate and one's called bad concatenate. Bad concatenate adds a 1 at the end of every string. And in the actual test, which is the second class, the good result just tests the good result is the result of the good concatenate method, and then I'm just testing whether it equals the expected output. And the bad result does the same thing, but obviously the error on the right shows that it doesn't show that, because I imagine that we're going to need that for the IAs. It would make sense to, which is the only reason I code it, because it's useful. So yeah, that's types of testing.